Live from New York, it's Ask This Engineer.
Hey everybody, it's time for your favorite live goth electronics show with hiccups. It's Ask a Hiccupy Engineer with me.
I'm good. Do you want me to scare you?
No, don't do that.
Turn on the news. Quick.
Okay, so you're making me hiccup more.
Yeah.
It's me, Lady Ada, and with me is Mr. Lady Ada, who really doesn't like when I get hiccups because he scares me.
Yeah.
And we have an exciting show for you tonight with all sorts of new products, new news, videos, demos, projects, robots, and more.
That's right.
What's on tonight's show?
Well, I'm glad you asked. Hiccups.
I totally got the hiccup so bad.
The code is PyCom IoT. I'll tell you why as soon as we get going here. Lady Ada will hiccup through an overview of the show and tell, pack in a mailbag, stop by, and well, he's a letter, he's not a mailbag. Yeah, anyways, it's an envelope that talks. Time travel, look back in the world of hackers, makers, artists, and engineers. A little bit of Made in New York, some factory footage, some 3D printing, some new products. We'll answer your questions. We'll have a top secret
Maybe more than
thingy.
one.
I'll love that. We'll have a trivia question, all that and more on Boop. Ask an Engineer. Yeah. Okay.
Shoot. Yeah. Okay, so let's kick it off.
All right. Well, the code is PyCom IoT. So
10%
use
off.
that 10% all the way off. You know what the scariest thing is? Not saving 10%
Scary.
on checkout.
No, that didn't do it.
Yeah. Okay.
But you get 10% off everything except
gift certificates and AdaBox. Yeah.
AdaBox.
Yeah. So that's going on right now.
Yeah.
Right now. Some other things. You're watching Ask an Engineer, 8 p.m. every Wednesday. Longest running live electronics show that I know of. No one's challenged that claim.
We will not stop. We will not quit.
Yeah.
We will not give up.
No. And then we also do show and tell 7:30 p.m. every Wednesday.
Yeah.
My favorite half an hour of the week. If you're checking out and you're in New York City, when you check out, if your zip code is one of the places we do same day, it'll show up and you get same day. And we also have our UPS free offer, $200 or more for your UPS ground. Not that weird smart post stuff that gets lost. It's UPS ground that actually gets you. So, Lady Ada, we had a show and tell. This was an epic show and tell. There was a lot of good projects. There's always good projects. This one in particular had a lot of good projects.
I like that it was a mix of new people.
Yeah.
And some people who've been on the show before, because we can, when they've been on the show before, we can see the progress they're making.
A whole bunch of different projects.
Okay, we had.
But we all came together.
Yes, together.
Yeah. So what do you got?
Projects. Okay, so we had like 10 people.
Yeah.
Starting with, we had Noah and Pedro. They're from Adafruit Southeast. We're going to show their video. They made an oval light for smartphone filming. So it's like a ring light, but it's oval and it goes around the phone. So it's actually kind of smart. It was kind of inspired by the hang lamp, but they decided they wanted to make a oval light for their phone instead, because they do a lot of outdoor filming with their phone. And there's also, Noe made a acrylic fidget toy, which we'll have a video for. Tony D is going to the Emerald City Comic Con and maybe going to cosplay as Tony Stark, which makes sense because Tony is just like, you don't have to get a new identification card or whatever. And also did a stream last Friday on the ESP32 with MicroPython. Check that out if you have an ESP32 dev board and you would like to run MicroPython on it. JP, John Park, he did a preview of a tutorial. He's working on the CurieBot with the Arduino 101. It's a little round robot. It gives you Pez. It has underlighting. It's pretty cool.
Yeah.
So he's going to be doing a tutorial and video with that. And then we go on to non-Adafruit peeps. Started with Eric, who made dead mouse ears with 600 NeoPixel LEDs, and they stream animations on them and shit. So work in progress, but looks really, really cool. Lots of LEDs, lots of wiring, a lot of power management when you get to 600 LEDs. Running off a feather, Matthew works at the Museum of Natural Science, and I can't remember what city, but he teaches a climate change class.
I'll tell you. I think I can find it because
Yeah.
there's a tweet. Yeah. What's that? Natural Sciences. North Carolina Museum of Natural Sciences.
Okay, so North Carolina.
Yeah, it's cool. Homemade
3D
AR
goggles.
AR VR.
Yeah,
goggles.
so it's like
so the students can see all sorts of stuff.
we used our tutorial where we made VR goggles,
Yeah.
like a Oculus Rift, but he put a webcam in the center
So it could do AR.
so you do augmented reality, which I think
Yeah.
is a really good idea.
Well, just a note, and this is just a little bit of maker business stuff. I just read that all the Oculus Rift installations inside of like Best Buys, they haven't been used, so they're getting taken out. So it's one of those things where there might be more people making their own and doing their own things at museums than this like multi-billion-dollar like Facebook acquisition thing. Like I've not
The Vive Revive, I've heard and seen people use the Vive, but I've not yet. I actually don't even know anyone
I saw
who has an
a
Oculus.
dusty like display that no one was using with Oculus. Anyways.
Well, Palmer Lucky's pretty lucky. Got $1
I-
billion out of
but
it.
But I think what's cool is there's people that can use this technology in a setting. So there's more students and more visitors to this museum that are probably going to see AR and VR than something that has a really high price point that's kind of hard to imagine purchasing.
Yeah.
Anyways,
So Matthew built the first class. It's DIY. I like how it's very skeletal. You can see what's how it's built. It's 3D printed, based off of our guide that we did a couple of years ago now on DIY. Oculus Rift type. We basically showed how to make a 3D printed body. Not the we showed the electronics, but not like the software stuff. We just showed here's where you place the center, and here's how you get a screen mounted. So he built that. Aiden has been messing around with 20-sided unstable icosahedrons. Have some cool properties, like they squish and they contract. Some more squishy 3D printing. Lon is working on a new ray gun. More ray guns. Always ray guns from Lon. This time it's a Rick and Morty prop. I don't remember the name of this ray gun, but it was like sold to a character, or some character sold to another character. And so he showed how he's like mocking it up in 2D and then using foam cutouts. And then he's probably going to come back and show that as he builds it. Sally got her new workshop set up. It looks really cool. And she's building like a resist jacket with a resistor symbol, and it lights up.
yeah, it's cool.
Very neat. She loves doing LED sewable art and very good at it. Probably the best in the world.
Yes.
Yeah, easily. And then C. Scott played us out with a discussion about hypertangents and how you can implement hypertangents as a gain function in your audio circuit to give you soft clipping, so you don't get harsh distortion. You get soft sounds get loud, but the loud sounds don't get so loud that they distort and then overwhelm the soft sound. So like a really nice filter, and is building new modules for his modular setup. So
very cool. Okay.
1 and 4, 1, 4, 8. So it's like 2 op amps in OTA and like 6 diodes.
All participants on the show and tell get an as seen on the show and tell sticker. Email support@adafruit.com if you were on the show and tell, and we'll send you out a sticker. And once again, thank you everyone who comes on the show and tell. And I think it's one of the best examples of technology empowering people to come together, show and share their projects. Some of these projects take a really long time, and we get to see different stages of them, and then eventually it's on our blog. And then the fellow who was from the museum said, oh yeah, like Adafruit's Learn system is our first stop, and that's where we got the idea to do this. So sometimes just showing your project or showing how to do something will empower someone to make something that they never thought they could do. He said something interesting, that the kids, when they see the VR goggles that aren't store-bought, that they're made, that's in itself a whole other conversation. So they're learning about science and they're learning about engineering because they can imagine themselves, because they can see all the components. They're like, oh, I can make something like that. So it's really smart.
Yeah.
Okay. Anyways, this is part of our Adafruit live series. We've been doing a bunch of live videos. We had Desk of Lady Ada during the last week. So we did the ultra low power one that was...
this is a preview of an upcoming new product, the TPL 5100. I talk about how you measure low power and putting your microcontroller in sleep mode versus using an external watchdog.
I used a monsoon power monitor.
Yeah, I love that thing.
Yeah. So that was one of the Desk of Lady Adas we did. And then we have a 2-part series. This is reverse engineering the Q-Touch.
Yeah.
Yeah, so we have part 1 and part 2.
So far, 2 parts. Probably going to continue this week and hopefully finish up by the weekend. But I'm working on reverse engineering the Microsoft Atmel, Quantum, whatever it's called, the Q-Touch peripheral, which is not documented in the AMD processor, the Arduino Zero and the Circuit Express and some of the Feathers. They can do peripheral touch. They can do a capacitive touch on all of the pins, or almost all the pins, but they don't actually release the source code on how to do that. They give you this precompiled binary. So in
which is tough. Which it's tough on us and everyone who does stuff with Arduino because it's all open source. So it's like, wait, what?
It doesn't. It actually doesn't make much sense. They should have at least released some sort of like.
So you did part 1 and part 2, and you started with IDA. It's an app, and it's a
decompiler.
it's a binary
disassembler.
It's a binary disassembler.
Yeah.
And then you can start to see the registers and more.
Yeah, we did. We're going with a two-pronged. Well, it's going to be three-pronged shortly. Two-pronged approach, where I'm linking the code in and running the Atmel Studio example, and then stepping through it with my debugger. And so, even though I'm not stepping through every assembly language, I can step through like as it does function calls into the library and seeing, in that register, the memory locations that are allocated to that peripheral, I can see what's changing. So I can start mapping out, if I change what pin I'm trying to do capacitive touch on, which bit changes. So mapping the registers that way. And then also disassembling the binary itself, and if there's a function called enable PTC, and you see all it does is turn on a bit in a register, I know that that's the enable bit. So also basically using the debugger for like live analysis, and then doing a static analysis at the same time. And then the third method I'm kind of using is looking at other peripherals, because they're going to reuse some of that the mapping, the way that they set up their registers is not going to be that different. So I've started mapping. I'm almost done mapping out the registers. So the next video, probably in the next day or two, is going to be actually starting to split the code in half, where I call the binary for like setup, or I only call it for initialization, and then I take care of the rest. Like basically starting to pare away the unknown and replace it with my code, and see, like if you replace a little bit at a time, I'll know if I get something wrong, but I'm pretty confident. I think I'm going to be able to get it going in a couple days.
So if you want
to
see the process of reverse engineering and some of the trial and error and some of the tools, this is a really good video series. On Friday night, we were watching Micah's reverse engineering exploration, and that really inspired us. It was neat to watch someone else kind of go through, like, here's the experiments I do, here's me in a hex editor, and then here's all the different tools. So anyways,
I'm doing like a known binary attack, where like I have the binary, so I just have to, and I'm pretty much, and I have access to linking into it, and I have hardware that I can use to debug it.
And the names make sense when you look at them.
And they left symbols in, so it's like not too bad. Like they left the names of the functions, and so even though I don't have the register names, it's like it's kind of obvious what they do. What Mike has been doing in her videos is actually glitching I think the Ethernet controller, and getting it
for
to
some
dump,
TI Internet of Things thing,
and getting it to dump out the firmware. So she, like, oftentimes these microcontrollers are locked; you can't read the firmware out. So you're kind of like, well, if I can just get the firmware out, then I can actually do the analysis. So she's trying to get the data out of the chip by glitching it, and like just as you request data through the Ethernet port or whatever, I don't remember the port, whatever that she's getting to, you glitch it right at that moment, and so that buffer, instead of giving you, just like, the response text, it might give you all of the code for the microcontroller. It might screw up. You just do it a couple thousand times until, like, you luck out, gives you like a chunk of
check
binary
out
code.
Micah's channel. We usually retweet it, and we posted about it, but anyways, go on YouTube and look for Scanline. Okay. Also, this week, Tony D had the ESP build, the firmware build video. So if you want to put the ESP32 build on, I think a couple different devices.
MicroPython, So right now we have the low-pi stuff in the storage you can use.
Yeah.
The ESP dev board that we have in the stuff,
Yeah.
and we also have the Rover, which is the like a Val board, has more things on it.
Yeah. So check that out, and then he's going to have another one probably tomorrow. With the frame buffer stuff he's been working on. So do check those out. It's part of our CircuitPython series of things we're up to. It's our educational build of MicroPython. A couple little updates that I have, because I like showing this in progress. We got some other, this is Blink of the Snake. A couple other little graphics as we get closer to shipping CircuitPython. And you can see,
funny.
Yeah, we have the little, like, because you can write your name on the back of the board.
Yeah.
So anyway.
And this is the world egg.
Yes. So that's the latest with Blinka. Okay, mailbag. Every week we have a all-company meeting. It's called State of the Fruit. We also read your emails, and we read them here on the show. This is, I think, it was Kevin. I would like to say I am enormously impressed with Adafruit's customer support following my initial post on the forum and then contacting support directly by email as requested and following their instructions. I've already received a message telling me my order is on the way, only the postal service can screw it up now. And all done and dusted with a few days. Well done, guys. And then he talks about how he didn't get an order from another company, so I will just move on. But that is, Kevin, thank you so much.
Thank you, Kevin.
And
thank you, Patrick, for bringing us the news.
That's right. If you email through our contact form and you have some nice things to say about us, maybe you'll see your email, letter, tweet, forum post, whatever, on mailbag. Okay, time travel. This is when we look back in the world of makers, hackers, artists, engineers, pioneers, and just fun stuff. So happy birthday.
Who's this?
An Wang, Chinese-American engineer and businessman, founded Wang Laboratories.
Oh, wow.
This is where it came from.
That's Wang. That's Wang.
Dr. An Wang, a Chinese-American computer engineer and inventor, co-founded a computer company, Wang Laboratories, which is primarily known for its dedicated word processing machines. Wang was an important contributor to the development of magnetic core memory. Now check this out. This was one of the first logos.
That's a sweet logo.
Later on, probably seen some of these machines. And then for the folks that remember this is what one of the
Wang Terminal
looks like. And this was one of their advertisements. What could you do with a statistics and number crunching computer that starts at $7,400 and has 16K hardware, basic language, and 28 major peripherals? Plenty.
That's pretty good, actually.
Yeah.
For back then.
Not too shabby.
16K?
Yeah, not too shabby. So that's our time travel of the week. Also, still celebrating Happy Chinese New Year. It goes to the 15th,
Yep.
Year of the Rooster. And also in the month of February on our site, African American History Month. And this week I wanted to talk about someone who means a lot to me. So this person is John Henry Thompson. And John Henry Thompson is the person who invented Lingo, the scripting language for Macromedia Director. And he obtained the highest engineering position. I think it was chief engineer at Macromedia. And I remember, I had this book. I remember.
So is Lingo, is that what's used
it's the scripting language.
Script Flash?
Well, see, Flash came later.
Yeah, I
so
know.
Director Shockwave, Flash later. Lingo was a scripting language for Director.
Was
it's
it
a little
like a
different.
predecessor?
Flash was a little different, but yes.
Okay.
Yeah, because Director was used for CD-ROMs and executables, and then eventually there was the Shockwave plugin, and that could be used for the web, and then eventually Macromedia Flash.
I vaguely remember Lingo.
Yeah.
It's been a long time.
So
Still, very neat.
Thompson studied at the New York Student Art League and Boston Museum, where he earned a degree in computer science and visual studies from the Massachusetts Institute of Technology in 1983. Thompson was the principal engineer for Macromedia Director and the inventor and developer of Lingo and XObjects.
Wait, so he got a course for? Wait,
so.
where did he go to MIT, sir?
Looks like visual studies.
Oh, yeah. So he did a dual 6 and 4. That's awesome.
And he was a professor at the NYU Tisch Interactive, so ITP.
Yeah.
So anyways, so I wouldn't be doing what I'm doing now if I didn't use Director, because that changed everything, because I was using Lingo script to move graphics around. And CD-ROMs, I'm a little older, so like we didn't have the internet, so you make a CD-ROM. And it was just like, oh my gosh, you could make anything with this. You could play videos, you could script it, you could do timelines.
There was like
timelines.
Yeah.
Anyways.
I'm still a little partial to HyperCard. But.
Sure. But this was neat.
You know, it's funny. HyperCard could have become the scripting language of the
Yeah.
internet instead of JavaScript. It could have,
But here's the thing.
but it didn't.
John Henry Thompson, when people talk about the people who really changed computer science and the pioneers of industry, you rarely hear about him. So that's why we have John Henry Thompson.
Did you ever get to meet him?
No.
Oh.
No.
So
But I think his son retweeted us.
Oh, cool.
Yeah, I think his son is doing like 3D modeling.
Oh, cool.
Like kind of doing other stuff.
Yeah.
He has a YouTube channel.
Vermal.
Yeah. Anyways.
Nice.
Next up, open source hardware. We're an open source hardware company, and we have learn guides. Lady Ada, what were the learn guides this week?
Well, I think we didn't have a ton this week, but we had, from last week we had the portable mini time-lapse camera that known Pedro, that was last week's Wednesday project. Did we talk about the JTAG debugging? I don't remember. know if that
I don't remember if we did.
Well, I'll mention again. So there's the JTAG debugging feather wing that Mikey Sklar did. So that allows you to, if you want to use GDB or you want to connect your J-Link directly to your feather, this is a little add-on helper that will make it easier for you to do so. There's also a tutorial from Scott's friend, a kombucha thermostat with CircuitPython. So this is like a demo trying out CircuitPython with a temperature sensor and using it to brew kombucha. So you don't have to pay $5 at the bodega. You can make your own because it's just like water and this mold. Apparently it's delicious.
Yum.
And then we've got the tutorial for the LSM9DS1. That was last week's 9DOF sensor. NeoPix Arcade Kit. This is a little 1D Pong game from... What's the name of the person who made it? Can you make it?
Which one?
The 1D arcade. I can barely see what the.
Yeah.
Yeah, can you give it? Oh, iTap Arcade.
Yeah.
Yeah, and then make it bigger again because it's a little easier for you to see. And then the camera LED ring light. That's this week's 3D project. I think that's it.
Okay.
I think that's it. And then the crypto countdown case was last week.
Do you know how many tutorials we have now?
Lots.
You want to take a guess?
Like.
1,159.
Oh.
Okay.
Good.
All right. Some made in New York factory footage. We like playing this stuff. So this is placing the Charlieplex pixels, I believe,
Yeah.
with our Samsung 482 that can kick out about probably could do 20,000 components per hour on this run.
Is this slowed down? This looks pretty slow.
I think it's
Oh yeah, I think it was slowed down for a moment there.
yeah.
So it's like that's correct speed, and then it went
Yeah.
slow.
Yeah, all phones can do slow now.
Yeah.
And then this is some footage from when we're dipping the nozzle for the selective solder machine.
This is like fluxing, maybe.
Yeah, and this allows us to do through-hole components.
Yeah.
So we don't
That's
have to hand
cool.
solder those anymore. So I got that. So
There you
can
go.
see.
That's how you.
Yeah, and then that's
Oh,
where the
nozzle.
little solder comes
Yeah, you
out
can
of.
even see a little bubble of solder.
Yeah.
That's it. That's how it works, and then it just
Yeah.
uses that to touch the pads.
And this is us changing reels.
More reels. More reels. More reels.
And then
More.
this is just a very fast series of photos played quickly of some of the stencils. And if you look close, it's like, oh, there's Circuit Playground. Oh, there's a floor. There's a phone. Oh, look.
You can see, like,
Neopixel.
NeoPixel.
NeoPixel. Have it. Yeah, so
Yeah.
that's what it is. So that is our made in New York City series of videos. Try to do these every single week. Some businessy stuff, because we got some businessy stuff going on. Don't forget to sign up for our spam-free newsletters on adafruitdaily.com, completely separate from Adafruit.
Which topics do we have?
Right now we have 3D printing, we have electronic tips, we have wearables cosplay, we have MicroPython, and then we also have Maker Business. So if you look at some of the strategy and the arc of what we're doing with Adafruit and then what's going on in the world, that's where a lot of these things are. So the Maker Business one, I work on this with Tom.
Yeah.
And that's pretty good. And we include a lot of stuff on, we not only want people to, look at our code and look at our hardware, make great hardware and code, but some of the business practice, some of the ideas that we
Yeah.
have. So that's our,
Yeah, it's like the Maker Business one. I think is like my personal favorite because it's what's happening in the maker industry. So it's
Yeah.
like you want to hear what's going on with 3D printing companies or Instructables.
yeah, like
or
sometimes we'll even put things
whatever.
like how we figure out which bank to use.
Yeah,
You know,
and
all
then
this, yeah.
there's like weird tips like, hey, this is a really great payroll service.
Yeah.
Or like sales tax, how
Yeah.
to calculate.
So we also try to use it as a force of good. Like there's a lot of good companies and a lot of good things that happen. You always hear kind of all the bad stuff, but we do like working with some companies. And I have to do a shout out. Want to hear my shout out?
Wait, is it shout out time?
Shout out. Shout out to Chase Asaga, who came by because we had to open up another account for something else we're doing. Came right by, got a factory tour, was able to handle everything. Super easy. That's our CFO, Stella.
Yeah.
Thank you. Saved us a lot of time. 3D printing. Noah and Pedro have probably one of the most useful tutorials if you're really into the best possible selfie.
Well, you definitely want one of these because we're always doing.
We're always doing videos with cameras
You
now,
just turn it
with
around.
phones, yeah.
So it would be like when you're filming on one location.
Take your selfie to the next level.
Next level.
Yeah.
With glow.
Your hiccups are gone.
They are.
Yeah. All right. I'm gonna play this video.
Don't talk about it though, because they'll come back.
Hiccup,
In
hiccup,
this week's
hiccup.
project, we're going to build a new camera ring light for your mobile phone. This 3D printed lighting rig is a great DIY build for your photo and video projects. It uses an Adafruit trinket and NeoPixel LEDs. It's also portable and battery powered, or you can just plug it into the wall. Your phone snaps onto the 3D printed bumper, making a great lighting solution for your front-facing camera. In a previous project, we made a light ring for DSLR cameras using a 60 NeoPixel ring. This new version uses RGBW type NeoPixels, which produces much better lighting. Combining RGB colors together can create white light, but this just doesn't look too good on camera. RGBW type NeoPixels provide a dedicated white light, which produces much better color temperature. Here in the side-by-side comparison, you can clearly see the one on the left has a much more natural tone, while the one on the right has a lot of magenta. This is because the RGB colors are separate from the white diode, which actually has a yellow phosphor. This produces a better color temperature, which is ideal for photography. By adding 2 NeoPixel sticks to a 60 NeoPixel ring set, we're able to make an over-ring that can fit over the phone. The signal from the NeoPixels can flow between different PCBs as long as the data in goes to data out. Here's how the circuit works. We'll connect an Adafruit trinket to a LiPo backpack charging circuit for the battery. A slide switch will power the circuit on and off. For the battery, we'll use a 2500 mAh LiPo. The data line from the pixels will connect to a GPIO pin on the Adafruit trinket, along with power and ground. In the Arduino sketch, it's easy to add support for RGBW NeoPixels. In the NeoPixel object, all we need to do is change the NeoPixel type to NeoGRBW. Then in the loop, we can add a 4th color value in the color argument and zero out the RGB values. Here's how to attach the sticks to the quarter 60 rings. We'll use 2 sets of third helping hands to keep everything steady while we solder. Header pins will help bridge the connections between the pads. First, we'll need to tin the pads with solder and then slide a piece of header onto the pads. Let's see that again. Tin all of the pads with a bit of solder. Then keep the pad heated while placing the headers on top. You'll definitely want to use tweezers so you don't burn your fingers, and this helps keep things sturdy. This makes the connections much stronger than just using solder. Data in should always flow into data out, so be sure they're oriented correctly. Make sure to leave the N unconnected because we'll need to attach wires to the first NeoPixel with data in. We'll need long wires to connect the NeoPixel ring to the Adafruit trinket. The foam bumper is integrated into the NeoPixel housing, but you could always just adjust the design if you want to use it for a specific device. A separate piece will hold the electronics and clip onto the body of the NeoPixel ring housing. The battery fits into a protective housing and it has a T-slot which slides into the electronics mounting clip. These parts were printed on a 0.06mm nozzle, which actually reduces the total print time. The wiring from the NeoPixel threads through the hole in the housing. The NeoPixel stick has mounting holes, so we can use machine screws to secure them to the housing. We'll mark mounting holes on the housing and then use a Pro Needle tool to poke through the plastic. Then we can insert and fasten M2 size screws to create threads. Now we can secure the PCB to the housing with machine screws. We did the same process for the LiPo backpack and the Adafruit trinket. We laid it out like this, marked the mounting holes, used a needle to create the holes, and made threads with the machine screws. Now we can measure out some wires to connect the LiPo backpack to the Adafruit trinket. We use pieces of flex PCB for connecting multiple wires to the power and ground pins on the Adafruit trinket. Use tweezers and third helping hands to keep the flex PCB steady while soldering. Then attach them to the power and ground pins on the Adafruit trinket. Now we can connect the wires to power, ground, and the USB pin. We'll need to cut this trace on the LiPo backpack to enable the on and off switch. Then tin all of the pins and connect the wires from the trinket to the LiPo backpack. Now we can wire up the slide switch and connect it to the LiPo backpack. We can then secure the PCBs to the clip by fastening screws into the mounting holes. The slide switch press fits into a little cavity, and now we're ready to connect the NeoPixel ring. The mounting bracket fits over the bumper and clips onto the edges. Now we can connect the NeoPixels to the Adafruit trinket. We'll need to thread the cable from the battery through the holder and then slide in the battery. The T-slot from the battery holder slides into the groove on the back of the housing. Now we can plug in the battery and tuck the cable underneath. This 3/8 to 1/4 20 thread insert will make it easy to mount this to any tripod accessory. This cover provides some soft diffusion and a bit of protection to the NeoPixels. This swivel head makes it easy to position the light upright so that we can attach to a tripod or a selfie stick. Having the ring light directly attached to the phone itself has a lot of benefits. It gives you an untethered experience that lets you take it with you anywhere. But of course you don't need to have a camera phone attached to it because it works pretty well as just a light. So if you ever need really good lighting, RGBW LEDs are definitely worth checking out. I hope you found this project insightful and maybe even inspires you to DIY something of your own. Let us know what you think of this project in the comment section. Thank you so much for watching, and don't forget to subscribe to the Adafruit channel for new videos every week.
All right.
Yes.
So,
Ring.
yeah, physical project.
Yep.
Okay. Next up, we have.
Cool and bright.
Yeah, this is another one of the fidgeters.
This is acrylic fidget.
Fidget. And we got one more time lapse. Don't forget Wednesday Hangouts. That layer by layer, and that's all on our YouTube channel and more youtube.com.
More 3D stuff that you can extrude.
Yeah. Okay, Lady Ada, before we get going into new products, the code is PyCom IoT.
I'm ready.
You are? You're hiccup free.
I'm hiccup free.
You're fueled. You've been training your whole life for this. It's time.
New.
All right. Okay.
Yay!
So new products. All right.
This
First
is the
up,
time I prepared for.
here's a bunch of wires.
It's wires and a breadboard. We have a bunch of these breadboard and wire kits. They're pretty handy if you kind of want to get started all in one, and they come with really nice pre-cut, bent, and stripped wires. So it's a couple bucks more, but you get a really nice breadboard. It's a higher quality breadboard as well with really nice silkscreen and of course like a 70-something wire. So it's a pretty cute little kit.
Okay.
I can show it on the hover just because it's
Okay.
just to show how many, because it's tough to see. So you get this breadboard, which I really like. It has the black and red markings. It's a really pretty breadboard and really good quality. And then, yeah, you get like a whole bunch of little jumpers, little teeny ones, medium ones, long ones, and like super long ones. So you can use them for long breadboards or short ones or whatever. But basically, it's they're ready to go, and they're good 22 gauge ones, so they'll stick well and make for pretty breadboarding. Which, I like the long jumper wires when they first start, but once I've gotten a design done, I like to cut smaller jumper wires, so you don't get like cables all over the place. So instead of like making your own, like this, basically you get these nice short cables instead.
Okay. Moving right along. A giant button. No,
It is a ginormous button.
no, it's not.
It's not ginormous.
The photo is deceiving because that's not the scale. But it's an RGB.
But it's so detailed.
It's a nice photo. We have
By
some
popular
we
demand,
have some other photos too.
we now have an RGB metal durable button. It's meant for use in projects that want a really good looking button, maybe a really rugged button. Don't have to worry about this breaking nearly as easily as plastic buttons.
Which overhead do you
I
want
got
to
this
use?
on the hover. I want to use the hover cam.
You're gonna use the hover cam
Yeah.
for everything? Yeah. Okay. All right.
Hover's easiest for me.
Okay.
So on the back, you get a whole bunch of pins. So you have the switch element. So this, it's a momentary switch. So when you press it, the two contacts connect. But apart from that, there's also 4 pins on the bottom that are used for R, G, and B LEDs. So there's one for red, one for green, one for blue. And I just have it hooked up to an Arduino that's pulsing through the colors for you. You just get your PWM going, and you can have any color you want. And so you can change it maybe, red when it's off, and then when you press it, it turns green to let you know that the status has changed. So it's like a status indicator button. Really nice. You just, drill a 60 millimeter hole up to a 1/4 inch deep, and then this comes with a O-ring and a nut for mounting, and then I just have it hooked up to this Arduino here so you can see. But you would just solder wires to the bottom contacts for connection. But yeah, RGB, that's what you've always wanted.
Yeah. Every time we had the one color ones, everyone's like, "I want an RGB one." So we did it. It's here. It's now.
We have RGB.
Yeah. Okay. Next up. This next product has a story, but this first is a video. So you see how that turns on and off?
Yeah.
Well, we originally saw this from our friend Naomi. So Naomi did this cool project where these LCDs would turn on or off, and she wasn't naked underneath.
She's wearing stuff underneath.
She's wearing stuff underneath, but everyone freaked out. Like you've never seen someone in shorts or something. So we saw those and we're like, oh my gosh,
cool.
do you know the supplier for these LED glass things? And we were able to get them. And she just tweeted just a few minutes ago. She says, oh great, because the factory that she got them from had a minimum order quantity. So now we're able to get those for makers. So I want to show this live because I think that's the only way you can show how this works.
And I don't have a top, but I do have
Yeah.
a single piece of glass. This is what it looks like when it's off.
Yeah.
And it's not going to be, completely clear because it is polarized. So it's, it does block some light. It's gray. You can definitely see through it. But then, right now I have it hooked up to, the same Arduino, basically turning on a pin high or low once a second. And then this is it basically turning dark or light. So the way LCD glass works is it's even though you put a voltage on it, once it's switched over to black, or clear, it doesn't use almost any power. So if I disconnect it, just when it turned black, I can actually, hold it up.
Yeah.
Eventually it will start fading away. There is some discharge, but you can see how dark it is. Now, it's not completely perfectly blackout. It's not. It's very dark.
Yeah.
But if you put a flashlight behind it, some light will come through. I believe it blocks, at least 95, maybe 99% of light.
Quick question, can you cut it?
No, it's glass.
Oh.
So you get it in this piece, It has electrodes on the end that you can solder to carefully, or you can clip onto.
Yeah. The race is on. Please, someone start making sunglasses. You're going to do it. Just make sunglasses. You're just going to do it.
But this one I like because I've had LCDs that need 10 volts. This one needs only 0 to 5 volts. And what's interesting is that as you go from 0 to 5 volts, it does get darker and darker. So if you don't want to have it be like pretty much pitch black, you can put on like 2.5 volts, and it'll be kind of in between. And then, the only thing is that this is, I can show it with the RGB LED behind it.
Okay.
So, you can see.
That's pretty good.
You can like barely see the light.
That's cool.
But it is pretty dark. It's basically dark enough that I wouldn't worry. If you didn't have a backlight, if you didn't have something light behind it, if you had it pressed up against something like
cool.
like text, or if you wanted to block out, and basically non-lit object, you won't see it.
No Adabot.
You're pretty much not going to see it.
No Adabot. All right, so that's cool, and special shout out and thanks to Naomi, who not only did this project. You can find it on ImageURL, or just search the internet for like this, or look at our blog, and you'll be able to see the first project that we saw with this, and now we have them available in the Adafruit store.
Yep.
Okay, next up.
Very cool. Very delicate, so just be careful when you use them.
Huzzah!
Huzzah! We have, this isn't a new huzzah, it's basically the huzzah, the feather huzzah you know and love, but now it is soldered. So we now have 2 more versions of this very popular feather board. This version has plain headers on, plug into a breadboard, you don't need to solder anything, it's ready to go. So it's, an extra $1 or $2, but it's very easy to use, you do not need anything. And then we have another version with stacking headers. So if you'd like to stack something on top of it, like a feather wing, or you want to connect, jumper wires into it or something, we also have a version. It's an extra $1 because the headers are more pricey.
Oh, I see. So this is
plain, stacking,
stacky, plain,
stacky.
If you want in a breadboard,
Use either.
You can use either, but you can use plain, or you can use stacky.
Stacky is better if you want to put a feather wing on top, an OLED feather wing, or one of our NeoPixel featherings, or a radio or whatever.
That's where they go.
That's when you would want to go with the stacking version. So this is just for convenience. A lot of people were like, "Well, I want to have a classroom pack or something, and we don't do any soldering." Yeah. This way, you don't need to do any soldering.
Okay. And then the reason for the code tonight is we have a bunch of the PyCom stuff in.
Yes.
Hooray.
We have 4 items from PyCom IoT.
Yeah.
So starting with the Wi-Fi 2. So this is, we've carried the Wi-Fi 1, which I believe, I think it was a CC3200 chipset from TI. This one uses the ESP32, so it's a much better processor, can do a lot more. They ported MicroPython to this processor, and then also contributed the ESP port back to the MicroPython project. So that's really nice if you want to make your own custom.
Shout out to Fred and Joe.
Yeah.
Because we were corresponding.
Creds.
Yeah. Thank you.
Yeah, okay.
Appreciate it.
But that's not the reason we carried it. It's a good product,
and of course, Damien, who made...
Damien, of course.
Yeah.
Who did it. This is kind of nice if you want to, it basically has a Python...
Now you got the sneezes.
I got the sneezes and the hiccups. So you got the Python interpreter built into it. There's Wi-Fi and Bluetooth. I think the BLE stuff is a little new. I know that they're still working on that with ESP32. But for the most part, things are working. You can also update firmware pretty easily. Has a NeoPixel as a button, has these pinouts. You can solder it straight on. Looks like it has an antenna selection. So if you want to go with a UFL, you can do that. We have antennas in the store. So this is just Wi-Fi and Bluetooth on the ESP32 with a Python interpreter.
Okay.
Next up, this is a low Pi. It's a bit bigger because it has the ESP32 plus Semtech, I think SX1278 or whatever, 900 megahertz LoRa radio. So it's all combined in one. So you basically get, your Bluetooth energy, your Wi-Fi, your LoRa. You can do, long range with LoRa, shorter range with Wi-Fi, and ultra short range with Bluetooth. But, each one has its own benefits. So with this board, you kind of get to do anything and everything. And you can pass data between the protocols as well.
No excuses. All the protocols are there. Okay.
Yeah.
And then
antenna kit.
Yeah, there's an antenna kit that you can get because I showed a picture of it, not included with this or the board that goes into
The
it.
antenna kit's for the LoRa. We actually, so our other LoRa boards, we usually just tell people, because they're low cost, we tell people to solder a wire. But if you're having this nice board, maybe you want an
Wire.
antenna kit. This antenna kit comes with a UFL to SMA connector and a 900 megahertz antenna, perfect for use with your low pi. It'll also work with any of our other 900 megahertz devices because it is just a 900 megahertz antenna. So,
Yeah.
if you want to use this with our LoRa or RFM69, it'll work as well. But this is specifically, we're carrying it for
Yeah.
people who get the low pi. They should pick one up so they don't run the LoRa without an antenna.
Okay. The last product of the night.
This is like a breakout board for the Wi-Fi 2 and then the low pi that we just showed.
Yeah.
So you get a USB to serial converter chip. You get a breakouts for everything. You get a SD card socket. So a couple little extras.
Yeah. Expansion board.
Maybe a battery charger too. I don't remember. I think you get a LiPo battery charger booster or something. Check
Yeah.
the product page. I don't remember if there's a boost converter. It looks like there's a battery charger though, built in because it says charge.
SD card.
Yeah, the SD card I got.
Yeah.
So it'll add-on basically gives you a bunch of extras. So while you're developing, it's a little easier because otherwise it's like, well, you want to get a serial console. This kind of makes it easy. So I suggest getting basically one of these if you're starting out with the Wi-Fi or the low pi.
Yep. Okay. And with that being said, Lady Ada, that was new products.
New.
Good work. Okay.
New.
Everybody's favorite time. Don't forget to use the code PyComIoT, 10% off for a couple more hours. Do it now. Let's do some top secret. And then we'll answer some
I'm ready.
questions. All right. From the Adafruit Vault. So I just like showing this graphic. Boards of a feather flock together. That's right. We have the best of Bluefruit combined with the best of Feather, which gets you... Oh, that's nice.
I'm hiding it.
It's not a... Wait. It's
Ta-da!
out. Nope. Wait.
This is the new NRF52 feather that we're coming out with. This is a feather main board. It's
Okay.
really nice. K-Town's
NRF
52.
52. And who makes that?
This is a Nordic chip.
Nordic. I knew that.
No, they don't know.
Yeah. Not everybody. So it's
Some
a
people.
Nordic NRF 52. And
NRF52.
why is it nice? Why is
It's
it good?
nice because it's a Cortex M4.
Okay.
It's got a lot more flash and RAM than the NRF51, which means you can actually start running. You can run Arduino code on the NRF51, but the 52 is way better at it.
Okay.
Really nice peripherals, lots of
Yeah.
analog digital inputs. I2C, SPI, UART, little module. We stick it on a feather board, you get an SWD breakout maybe. You get a reset button, you get a battery charger, USB connection, USB serial port, bootloader. Really easy, and it's basically the NR52 is a little bit more expensive than the NR51, but it's not as expensive as this whole separate microcontroller. So this will be the least expensive way for us to get people onto Bluetooth, and it works great with our app.
So we could have like a Bluetooth like MicroPython
absolutely
type
MicroPython. I think
Circuit Python type thing going on.
I think it's MicroPython has been partially ported to the NR52. We'll probably continue that port, maybe finish
Okay.
it. You don't get native USB. That's the only thing that's missing on this chip, but it does
Yeah.
have quite a lot going on.
All right, this is cool.
Nice chip.
All right, back in the vault.
I can also show something else if you want to show something.
Oh, really?
Yeah, I don't know.
Phew, okay, gonna open up the vault again. Can I even do that? Yeah. How do you open this vault up? Okay. Yeah, what do you want to show?
Well, I've got this we just finished this right
Whoa.
before the show. This is an 8x8 APA 102 2020 matrix. Maybe I'll put this behind this.
It's a crack in the universe.
Maybe
Okay.
darken it. Actually, I want to see if this is. Oh no, I can't do both. Hold on.
What are you doing?
I need to get another micro USB cable because I might destroy everything.
Do you want me to help you?
Oh, hold on. Let's see what's on the other end of this cable.
What? It never ends.
No, I got it.
Oh.
Okay, so let's put this
It's a
in.
really long cable.
Yeah. Plug this in,
Okay, so you can plug that in,
and then I'm gonna use this as my darkening filter.
So we'll use this. Oh, look at that. That's cool. That's a good idea.
Yeah, so you can see exactly how incredibly bright it is.
Yeah.
Woo! No, I didn't disconnect. You have to disconnect it exactly at the right time.
Okay.
Hold on. I'm gonna do this. I can do science.
Yeah.
Okay.
So you're gonna. Whoop.
There you go.
There you go.
Oh, you know, like, okay, not so great. But anyways, extremely bright
Okay.
LEDs, 64 of them on
Alright.
a teeny little square.
On Descaladiata, we'll put that under the microscope. Maybe
Yeah.
on Thursday night. Okay.
So this is what it looks like when it's off. But yeah, very
Okay.
bright.
All right, I'm really shutting the vault this time.
Okay, go shut that vault.
Woo.
I'm gonna keep messing with this.
Okay, we're gonna answer some questions. Post them up in the chat. Don't forget, code is PyCom IoT. Oh, did you want to show the?
No, I just got this dark
Yeah.
finally.
Oh, all right.
Like
That's
I'm
fine.
censored.
Okay. Yeah, post up your questions.
It's really dark.
Woo! All right.
Okay, questions? Questions.
Yeah.
Yeah?
Well, their questions are for the. It's not out yet, so I can't do those.
Not out.
Ask-
Yeah, no asking.
ask,
I'm not gonna do. It's not out yet. If you guys
yeah.
ask questions.
Yeah, y'all have. Let's. Okay. All right. I'm having trouble using the controls when I play my N64 game on the RetroPie. Any ideas? I'm using a Bluetooth keyboard.
Ooh, you know. Well, first off, try using retro game. Like we have native I/O controls that might be faster because it's hard to tell. It could be the Bluetooth. It'd also be like Nintendo 64 is a little bit tough to emulate. It could be having trouble emulating something like that. Try using like NES. NES emulators, like they're very, very fast on the Raspberry Pi, or much faster, so you'll have more luck.
Okay. I'd like to add 5 gigahertz Wi-Fi support to my Teensy project. What do you recommend?
I do not know of a single 5 gigahertz Wi-Fi module,
Okay.
so I don't know.
Next up, is Circuit Playground Express Rev D the final version? Are there any known bugs with it?
There's no bugs, but it's not the final version. We're already onto Rev E, and once I get Rev E in a good location, Rev F will probably be a cosmetic change. So probably Rev F or Rev G will be finished.
Okay. What's a good place to learn Minecraft Pi Edition coding? I think on the raspberrypi.org site and on the Microsoft
have
site they have
Tutorials, yeah.
they
We also have a book.
But on the Microsoft site, I think they have a curriculum guide for teachers now.
Oh, cool.
Like I just think I read that like
Yeah.
a week ago. Yeah. Next
also
up,
have a good book.
Internationally, what does someone need to do for permission to activate a LoRa network, or can you just plug and play?
You can just plug and play. I mean, as long as 900 megahertz is in the industrial band for your
Yeah.
country. I mean, like you'll have to look at what UTC. Oh man, I can't remember the name. There's 3 different zones, and so just make sure that in America 900 megahertz is one of the frequencies that you can use, but not every zone, ITU zone.
Yeah.
So, there's 1 or 2 ITU zones. I think 900 megahertz maybe isn't one of the frequencies. You use 433 instead.
Yep. Also, do you know how many pounds of solder we use here a day with the selective solder?
Probably like a pound or 2.
Yeah.
A day.
Okay. I can do this one. What's the difference between MicroPython and CircuitPython? So MicroPython is for bigger, fancier, more powerful bits of hardware. CircuitPython is our open source derivative that works with all of our hardware.
It's a little slimmer, kind of like Microbit also made variations
Yeah.
to MicroPython to make it work better with their chipset.
And we wanted to keep parity with Python, so it's very Pythonic.
It's very Pythonic, but there's just some changes to the hardware API to make it easier for us to support.
Yeah, so we have
the
50
SAMD
something
chips.
wings, so we needed to make sure those all those work.
And it would fit into a
And it would be super
256K
tiny.
flash.
Yeah. So anyways, educational version for teaching that works with different
Other than
hardware.
the hardware API, it's almost identical.
Yeah. Next up. Can we use the LCD panels to modulate lasers?
I have absolutely no idea. I mean, I think a laser will. I mean, again, it blocks only 99. It only blocks like 99% of light, so some light will go through. I wouldn't use it to protect your eyes from lasers.
Let's speed around this.
It is meant to protect your eyes from welding. That's what they're usually used for. So, but that's not terribly bright.
Let's speed around all these. So we
Yeah,
can tell
yeah,
them.
yeah.
Okay. What schematic capture packages do you like?
I use EagleCAD still.
Okay, is the RGB switch common cathode or common anode?
I think it's anode. Look at the product page for the
Okay.
details.
Next up. I posted my question way up in the chat. Do I need to replay it? Yeah, please do. There's just a bunch of questions. What's the best way to get started with hardware hacking? How can I learn about all these components and their functions? Start building projects. Also, Bunny's coming out with a really good book. It's his journey of being a hardware hacker. That might be good because it's more of a narrative than just like take this apart.
I think,
but
you
by
know,
the way,
like,
take a lot of stuff apart.
Take stuff apart, or like find a project you want to build that's an easy beginner project, and then
Yeah.
as you build stuff, you'll learn. Right? You will, whether you like it or not.
Well, easy key back. Start to sign up on the product page. No ETA at this time.
No ETA at this
We're
time.
making them as fast as we can. Can the SDR be combined with Feather or your Python boards? Can SDR be combined with Feather?
Software-defined radio?
Yeah.
I don't have any software-defined radio boards. The only SDR we have is a receiver
Okay.
that's USB, not really meant for use with Feather.
What's a good method to attach a thermocouple to an IC package to measure the temperature?
It's hard to put it right on the package, but one thing you can do is you can use like an alligator clip, and if you put the thermocouple, you can kind of get the thermocouple kind of into the alligator clip a little bit, so it's kind of touching it, and then you clip that to your circuit board. And you take the rubber boot off. You know, that's not a bad way. You can also crimp the alligator clip onto the thermocouple itself, and then you use that as your thermal conduction. But like, you know, then you'd have to clip it onto something. That's kind of the only way.
Okay. How do you test the capacitance with a multimeter from the Lady Toolbox if the capacitor has short leads?
Use alligator clips, so you just get in there really close.
The revision changes on our boards. Yes, we use like E, F, G. We just do it alphabetical so we can keep track of it. Looking to use a rotary encoder to control a menu system on a 16x2 LCD with Arduino. Any good tutorials?
I think on a Raspberry Pi or an Arduino.
Looks like an Arduino.
On Arduino, there's a rotary control library and tutorial on the Arduino site.
Okay. This person wants to make a guitar effects module with a Pi 3. Got a thread in Linux musicians going. I'm lost on how to do such a project. Huh? How would
Well,
they do?
you would need to have both audio and in and out.
Yeah.
So look at our USB audio converter. It can do line in.
Yeah, the
and
Pi just doesn't do
line
that
out.
natively. So
No, it doesn't do natively. So you have to have a USB or something adapter that does audio
Yeah.
in and out. The USB adapters are nice because they're pretty good quality and it's just line level. And then you'd have to write the code that does audio recording, filtering, and then pipe it out to audio out.
Do we have a Feather, a small Arduino, or something that has HID driver so you can make into a small gamepad?
All of the Feather can do HID.
Yeah.
The 32U4 and the M0, the Atmel chips, they all can do native USB HID.
Okay. Let's see. I started experimenting with the speaker bonnet, and I'm also trying to use an IR receiver. I wanted to control MOCP with IREX commands triggered by the remote from Adafruit. Unfortunately, the sound plays through the bonnet, generates pulses, which interfere with I only discovered this after running.
Yeah. You'll need to power the IR receiver from like a clean power supply. Like, you might have to filter out your power supply. It's electrical noise, or you might need to just have a higher quality receiver, or it's just tough. I mean, like the speaker is going to be quite loud. It's going to use a lot of power on the 5-volt line, so you want to make sure you're not connected to the 5-volt line. The oscilloscope will help because you'll be able to see where the pulses are coming from.
Okay. All right. I think you got through most of them.
Okay.
Whew. Okay. Thank you. We got through like 50 questions.
Okay.
There's the questions. Thank you. You can also post up in the forums.
Yeah.
And you can stop by Desk of Lady to sometimes we'll answer this too.
Yep.
Let's remind everyone, PyCom IoT is the code. Let's give away something. What do you want to give away tonight?
I thought let's give away one of these LCD glasses because they're just so cool.
Yeah? All right. What is the... what are the rules for the trivia question?
The rules are if you've won before, you can't win again. Only one winner per my lifetime. Whoever
Yeah.
types in the question the way you want the answer in the chat is the winner.
Yeah. Okay. Here's the question. Who is known for inventing the Lingo programming language? We just talked about it a little while ago. And you can even just search in Google. But I think this is a good way to do the trivia because such an important person in the history of multimedia. Mm-hmm. So let's see.
Not the company, the person.
No, yeah, who's the person.
Person.
Yeah, who's known for inventing
Lingo.
the computer language, and also making Macromedia Director. And I guess you could say Shockwave. So let's see. Who's gonna get first tonight? Inventor of Lingo. We even had this on our website. Not Amelia Earhart. Not Geordie LaForge. Not 42. Not Russ. Congratulations, Chris Hines, John H. Thompson. What's funny is when you search for Inventor of Lingo, it goes to our post about him. Look at that. Isn't that
Sweet.
weird? Look.
Yep.
Yeah.
Nice.
Anyways,
You're about the only person who ever posted about that
I
guy.
don't understand. Okay. So, anyways, congrats, Chris Hines. Chris, email support@adafruit.com. You won. Congratulations.
Yay, you won.
Let me.
Chris Hines.
Hines. I don't
Hines?
know. You won. Okay. What is the
Hinsey.
product ID so we can tell our team?
It is
Which one?
3330.
3330. Tell them that you're the trivia winner. Your name is Chris. You won. Tell them PID 3330, and you'll
Use
get
this glass.
one of these
Great power comes great light blocking technology.
with great opacity. Okay.
I'm gonna make this thing really glowy.
support@adafruit.com.
We'll show this on the
Yeah.
Maybe we'll do a stream tomorrow. We'll show this off.
Maybe.
Maybe.
All right. Well, thank you, everyone. That's Descaladiata tomorrow night, probably, if you want to watch that.
Sweet.
Okay. Thanks, everyone. Ask an Engineer every week, 8 p.m.
Yes.
Special thanks to all of the remote Adafruit team members, all the folks that help out, all the folks that are here every single day. You know, when you buy electronics, this is who you're supporting. This is us.
Yay.
That's how we pay the bills here. We don't have any loans or funding or grants or tax breaks or anything like that. It's
Nope.
just us making electronics here in the USA.
We have one pen we've been using.
We have one pen that we've used for a while.
for the last like 4 years
Yeah.
for every show and tell.
Yeah. Yeah, I don't, that's,
No, it is.
I think it's even come from our when we were in an apartment.
Yeah.
We save pens.
Glorious.
So, anyways,
I'm just saying we're fiscally responsible.
yeah, we had our accountant write a letter about how we running things because why believe us?
Yeah.
So we have them look at how we run the company. Anyways, so speaking of, save 10%. It'll be okay. So we'll see everybody next week. Here's a picture of a cat, one moment of Zener, and then I'm going to play some owls. Got that owl over there.
Ooh.
Moment of Zener.